Alrighty, folks, I'm going to go over 2018 AP4. Essentially, once again, this is just a game of can you read the problem? Because apparently, what we need to focus on is how to read the problem and how to approach this. Part A, a lot of us got h prime of 6 correct, but then you didn't read the part where I told you to interpret the meaning of h prime of 6 in the context of the problem. Emphasis on context. So if you just said that h prime of 6 was equal to 5 over 2, and you said that it grew at a rate of 5 over 2, what rate? Or if you said that the height of the tree grew at a rate of 5 over 2, but you didn't tell me what time, that got marked wrong. So you're going to do 11 minus 6 over 7 minus 5, 5 over 2 meters per year. So this means that at time t is equal to 6, the height of the tree is growing at a rate of 5 over 2 meters per year. Emphasis on my three things. I have my noun, the height of the tree. I have my unit, meters per year, and I have my time. Time t is equal to 6 years. 1 point was for the average rate of change, and then 1 point was for my context. Part B was explain why there must be a value, at least 1 time t for 2 to 10, such that h prime of t is equal to 2. Now this one right here, you guys either fell into 3 categories. Some of us said differentiable and continuous, or you said continuous and differentiable. Some of us said IVT. And then some of us did the average rate of change from 10 to 2, and then realized that that did not equal to 2. And obviously, you needed to use something else if you can use 10 to 2. And then a couple of us forgot to mention the conditions for MVT because, of course, you kind of need the conditions here. You need to state them. So the first thing that you always want to do is state your conditions. And of course, remember, you have to be specific. In this case, it's going to be h of t. And of course, this is where you need to tell me that I should not see any its. Now, did I give you credit for it? I think for the most part I did. I can't remember, but I should not be seeing any its. So in this case, I also took off if you didn't give me the interval, and if they were incorrect. Remember that differentiability is an open interval and continuity is a closed interval. Oh, beta. So h of t is twice differentiable from 2 to 10, therefore continuous from 2 to 10. Notice how I have my open interval from 2 to 10 for my differentiability, and then for continuous, I have my closed interval from 2 to 10. Now, like I said, if you did 2 to 10, that's not going to work. That's not going to give you an average rate of change of 2. So there must be at least 1 time t for 3 to 5 such that h prime of t is equal to 2, which is equal to h of 5 minus h of 3 over 5 minus 3, which is equal to 6 minus 2, 5 minus 3, 4 over 2, or 2. Now, all of that is equivalent to 2, so there's no linkage errors there. So far this semester, we've been really good about linkage errors. I haven't seen a lot of that as of right now. Knock on wood. All right, and then for part C, 1 point was giving me the average rate of change, then 1 point was giving me differentiability implies continuity. For part C, you want to use a trapezoid sum with the 4 intervals indicated by the data in the table to approximate the average height of the tree over the time interval 2 to 10. Like I said, this is a game of reading. Notice how this one said average height. So a lot of us just gave me the Riemann sum, not the Riemann sum, the trapezoid sum, but you did not 1/8 that. If you only gave me the trapezoid sum, that represented essentially the sum of the heights of the tree for years 2, 3, 5, 7, and 10, essentially. Now, because we want to find the average height, we need to divide that by 8. Now, before I do that, let's make a visualization on what's going on. No, that's years. This is years. This is meters. So if I were to find the area of this, I'm going to get meters times years. Now, that's my unit if I were to find the area under the curve. Now, because we want the average height and we only want meters, we have to divide by years, which is why we're using the average value here to get meters. So essentially, my integral should be 1/8 for the integral from, 2 to 10 of h of t dt. That's what I'm essentially finding. Now, a lot of us, most of us, gave me the correct trapezoid sum, which is really good, but you guys just forgot about the 1/8. I'm not going to do the trapezoid sum, but 1 point was essentially using the trapezoid sum, and then 1 point was the approximation, aka including the 1/8 in your answer. Now, part D, remember that anytime you see anything related to respect to time, it's going to be implicit. So for this one right here, we're just going to have to use implicit, right, with respect to time. So we have low d high, in this case 100 dx dt, minus high d low all over low square. A couple of us did not take the derivative with respect to time, so you only got a maximum of 1 point. Some of us did plus instead of minus, and then some of us just forgot to include what x was. In this case, you had to find out what x was because they gave you that the tree was 50 meters tall. So you're just going to plug in at 50 is equal to 100x over 1 plus x. 50 plus 50x is equal to 100x. 50 is equal to 50x. X is equal to 1. So you know that x is equal to 1, and then you also know that dx dt is 0.03 meters per year. So at this point, you're just going to plug and chug and call it a day. Now, a couple of us did plug and chug. A couple of us simplified this, got it wrong, which meant that they didn't earn the answer point. And then a couple of us had too many parentheses where whenever I typed it onto Desmos, it gave me an incorrect answer. This was supposed to be 3/4. So Just be careful with parentheses because the AP graders will put in exactly what you write. So if you have an extra parentheses, they'll type in that extra parentheses. And then if that messes up the whole thing, then your answer is incorrect. 2 points was for the derivative, and then 1 point was for the answer. Now, I did give 1 point if you took the derivative, but it was incorrect. AKA, you took the derivative correctly, but you didn't do it with respect to time. AKA, you didn't do implicit. So that was just a maximum of 1 point. All right. This problem and the coal problem were a mess. TBH. Please, 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 please read, and please, please, please give me the conditions. The conditions problem should be a give me, right? It's an easy way to earn your points if you tell me that differentiability implies continuity and you give me the correct intervals. So please do that. I don't know why every single time I look at your grade scope and every single time I look at your FRQs, you're not giving me the conditions. Like, this is a Unit 2 thing. I've been hounding this since Unit 2. Differentiability implies continuity. So, let's remember that, because you'll need it in May. And I'm trying to make you guys get 5s, but right now, she's not looking too hot.